What's up, everyone? Hi. Welcome back to our channel where we're here to make math easy. Yeehaw! What's on the docket for today, Mr. B?
It's something I know lots about.
Oh yeah?
Yep. Some even say I know so much about them topics that I should have my PDH. I'm pretty much a doctor.
Wow, that's impressive. I didn't know that.
On the surface, it may seem like I'm not the sharpest tool buried underneath the shed, but it's more than what meets the eye.
Okay, so what is it?
What is what?
What we're going over today.
How am I supposed to know that?
What was all that about being a doctor and knowing everything?
I never said that.
Right, I must be imagining it. All right, so today starts a two-series video, all right, two-parter, where today we're going to be going over surface area of cubes and rectangles, all right, and then the next video we're going to be going over triangular prism surface area. All right, so they're similar in some ways, but they're pretty different too. So make sure you watch this video first and then move on to the next one right after. We're going to teach you two tricks today to make sure that this process takes you a lot less time and is a lot easier. All right, it's a very straightforward process if you follow these two tricks today. So make sure you watch both of them and then wait till the end of the video to answer our challenge question. And as many of you I've already talked to, we are going to have a competition coming up. It's going to be in celebration of our 100 subscribers, which I think is going to come up pretty soon. And whoever has been answering correctly the challenge questions, or answering Mr. B's questions at the end, will be added into a competition, a sweepstakes, to win a custom Mr. B t-shirt. I'm wearing one. I stole it from Mr. B today just so you could see what they look like. It kind of smells. I promise you'll get a brand new one if you're the one who wins. All right, so without further ado, let's get started. All right, so today we are going to be doing surface area of prisms. All right, so the prisms we're going to focus on today are cube and rectangle. I said that really weird. Rectangle. Rectangular prisms and cubic prisms, otherwise known as cubes. So I gathered a couple things from my house and I'm going to show you a couple things. So first, this right here is called a box.
Don't forget it!
Ooh, right? It's a box, but really what it is it's a three-dimensional shape that holds stuff inside. These are actually cards, right? And this three-dimensional shape is a rectangular prism, all right? And I know that because the faces are rectangles, all right? Every single face is a rectangle, actually, or the majority of them are, all right? And this is a rectangular prism. Here, this is actually what's called a net, all right? A net is a prism that's been folded out, all right? So that all we're talking about is we're not talking about the space that's inside the prism. What we're talking about, what's the space on the outside of the prism. So the faces, all right? And the faces are basically this, 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 and this. We call them sides, but in math we call them faces, okay? So these faces, what we want to do when we're doing surface area is we want to find out what's the space that all of these faces take up, okay? It's different than volume. Volume is the space inside of a shape, right? Basically, volume is how much it can carry. So this one can carry, I hope your birthday is awesome as you are, all right, cards. These are cards. And this shape has volume. It's a three-dimensional shape that can carry something. So we're not doing volume today. We're only focused on the outside. And to kind of show what I mean, I have a net that's not quite folded all the way up and taped. So if we took this shape right here and folded it out, we would get something that looks like this. Kind of looks like a T, a lowercase t, right? So this lowercase t has all the sides, all right? So if we take this one and basically unwrapped it, almost like we were gonna wrap a present and we just perfectly wrapped it without any overlaps, right? We can actually fold this all in together so that we can create a three-dimensional shape, a rectangle prism, all right? So this is one way of looking at a shape to figure out the surface area, the area of the surface, the outside faces of a shape, okay? So these two things are the same thing. The only difference is this one is together in a three-dimensional shape. This one, all the sides are flat down, right? As if it were in a box that we just cut the sides and they flap down. We cut the top and the back and flap those down too, okay? So with that said, what we're going to do is we're going to be learning about how to come up with the surface area of a shape like this, okay? So up on the screen, I'm going to show you right here, I'm going to show you a problem. And that problem is going to be what you're typically going to see for a surface area problem. It's going to give us a couple of measurements, but it's not going to measure every single one. All right, so what you have to pay attention to is what it does give you. Now, what do we know about a rectangle? A rectangle is a shape where the opposite sides are equal, all right, equal in length. So that means if I know that this side is 6 inches, which it isn't, but if I knew that was 6 inches, then I would know that the opposite side is 6 inches. And in a three-dimensional shape, that means that every single one of these sides that are parallel to one another are all 6 inches. Okay, so oftentimes in the problems you'll see they'll say like 6 inches for one of them, and you'll use that so that you can label all of them so that you know. Now in a problem like this, a rectangle prism, it's not going to be that big of a deal. All right, but that is something important to know. All right, so whenever you're trying to do surface area questions, you want to think, what type of shape is it, and what does that tell us? Okay, so let's get to this problem. All right, so here's our problem over here, right? Our problem is find the surface area of this shape. Now, what we have here is we have a shape that kind of looks like this, actually, right? And we know the bottom part is 5, this piece is 9, and the height is 12, okay? So, to do this one, we have basically this shape. It kind of looks like the smaller ones in the front. And it's kind of like that, right? Kind of matches. Now I'm just going to unfold it a little bit. Now the biggest thing is, I'm going to flip it over so it's not propped up so much. The biggest thing is, for each one of these sides, we need to know what the measurements are for the sides, okay? Because otherwise it's going to be a little confusing. You can't just guess. You got to make sure you're precise. Now I know the spaces of these don't look exactly alike, and that's just because I folded it and I didn't draw those lines exactly precise. This line should be over a little bit, and this one's not straight. But don't get too mad at me with that. All right, so with this, I know about our measurements. Now I'm going to put the measurements right here to show you what each one of these is. Because it's a rectangle, because all the sides are different lengths, we're noticing what gives us is this one's 5, okay? And then this one is 9, and then the height is 12, okay? And even though it doesn't look that way, they may say something like it's not necessarily drawn to scale, okay? So if you hear that, that basically just means just because it doesn't look like this one is smaller than this one, don't worry about that, all right? They have a problem, they change the numbers around all the time. They're not going to recreate a rectangle so that it looks accurate. All right, so just keep that in mind. All right, so I need to find the area of this side, this side, this side, this side, and then these two ends, the top and the bottom of the shape, okay? And so in order to do that, I need to come up with what the measurements are for the perpendicular sides. All right, we don't multiply the opposite sides, we multiply the perpendicular sides. So let me move this thing over here. Let's move Happy over here, all right? So what I wanna do is, let's find the area of this side, okay? Which in this case looks like it's the left side of our shape, all right here. All right, because if this is our smiley face right there, then we know this is that side that's folded over, okay? So for that left side, to find the area, I need to think, what are the measurements? Well, I know that the height is 12, okay? So I'm going to be multiplying 12, and so then the height is 12, so what is this measurement? Well, it's going to be the same as what this one is. And as we see in the picture, it says 9. All right, so find our left side, that's 12 times 9. Now, here's a tip. Always think, what sides are the same measurement? All right, so let's go through them and just come up with what the measurements are for each one, and then see which ones are the same. And you're probably gonna notice the trend. All right, so let's do that front part. Okay, the front is 5, and then the height is 12. So we have 5 times 12. Let's do this right part. All right, and that right part, the bottom is 9 and the height is 12. Is anyone seeing something that's the same? Our left and our right are the same. We're gonna get the same answer. So that means these two sides, they're actually opposite in our shape. We fold it together, and thus this side is opposite to this one. Opposite sides are the same. So that means when we are multiplying, cut some work out for you. We're only going to multiply this once. Don't do it twice. Unless you're the type of person that needs to go through each step, all right, methodically like that. But really what you can do is once you do the left side, multiply that by 2 and you know you got the left and the right side, okay? So now let's do the back. Now the back, right here, is opposite of this front piece right here, right? And that means that we actually have the same measurements as the front. So again, these two are the same. So because we have these two are the same, these two are the same. Can anyone take a guess about those two? The ends, the top and the bottom, those two are also the same. Okay, so let's just say the top measurement, again, if we fold it in together, the top measurement is going to be multiplying 5 times 9, okay? So 5 times 9, and that's the same thing for the bottom, 5 times 9, okay? So pay close attention to that. What they may do is they may have some sides that are all the same length, and you'll have to do even less work than this. But now I know I have to do 12 times 9 and then multiplied by 2, 5 times 12 multiplied by 2, 5 times 9 multiplied by 2, okay? So let's go ahead and do that. So 5 times 9, I know that automatically is 45. So that means this one is also 45. 5 times 12, I know that one too, that is 60. So that means this 5 times 12 is 60. Don't do more work than you need to, okay? Then we have 12 times 9. Now this one you may or may not know off the top of your heads. 12s usually are fuzzy for a lot of people. But think about it this way. 12 times 10 is 120, right? So we know it's gotta be less than that, all right? Because we had 10 groups of 12. So here we have 9 groups of 12. So if you need to do it out, go ahead and do it out. But otherwise, we know 9 times 2 is 8. Carry the 1 because it's 18. 9 times 1 is 9 plus 1 is 10. So 108, which means this one is 108. Okay? So now, in order to find the total surface area of this whole shape, we're going to take the area of each face and add them all together. All right? I'm just going to draw a line right here to kind of block out what we did with our areas, our separate areas. So let's add up the ones. 8 plus 8 is 16. All right, and then we have 5 and 5, that's 10. 10 plus 16 is 26. So I'm going to carry the 2. Then here I'm noticing I have 6 and 4. That makes a 10. Another 6 and 4. That makes another 10. So now we're at 20. Plus our 2 is 22. Let's carry that 2 to the next place. Then we only have a 1 in the hundreds place. So 2 plus 1 is 3. All right, so 326. And our unit is centimeters, and it is a 2-dimensional shape. All right, each one of these faces is 2-dimensional, so our answer is square. Okay, so the tip number 1, look to see what are the same. Don't do the work twice. Save yourself some time. Mathematicians are lazy, not because they don't want to do anything, but because they're going to find ways of doing the same work quicker. All right, so make sure you do that too. All right, let's get rid of this and let's do another one. All right, so we got another one. Now I'm going to do the thing right here. Now in this, I'm going to do another rectangular prism. And the reason for that is quite simple. To do a cube is very straightforward. A cube is made up of a bunch of squares. All right, so I have a cube net here. Each face is a square, which means that all the sides are the same length. So that means that this face has the same area as this face, as this face, as this one, as this one. All of them are the same. So once you find the area of one face, how many faces are there in a cube? Well, there's 1, 2, 3, 4, the top 5, and the bottom 6. So say this was a 2 by 2. So 2 by 2 is 4. So that means the area of this is 4. And we'll give it a unit of unicorn tears. So 4 unicorn tears. No, that's too sad. Let's do unicorn pellets. All right, so 4 unicorn pellets. That means since we have 6 sides, we take 4 and multiply it by 6. And we get 24 unicorn pellets squared. Okay, so every cube is actually quite simple, right? That's why we're not going over a ton of these, because I want you to really focus on the ones that are a little bit different, which are the rectangular prisms, right? Because we have a lot of different sides with a lot of different measurements, okay? So look right here, we have another problem for you. Now this problem has a shape that kind of looks like this. I don't know why it looks like that. It has a beard and kind of a, I don't know. I don't even know how to describe this. It's very interesting. Let's just look at it nice and close. Yeah, he's scary. He is missing a nose though, and really a forehead and really lines that connect his head. But anyway, let's not worry about that. So we have a shape that kind of looks like this, which the net, again, would be something like that, okay? Similar to what we have there. So, we know this front line is 6, which means that we also know that because this is 6, the opposite side is 6. Because this is a rectangle, opposite sides are the same. And then in this rectangle, we know this one's already 6. That means this one, which is opposite, is also 6. In the back rectangle, we know this one is 6 because it's shared with this rectangle. That means the opposite is also 6, right? So keep in mind, what is the shape? What is that going to tell me? So I know all those are 6. I know the height is 8, which means all of the heights, this one, this one, this one, and this one are all 8. And then we have our last measurement, which is 4. And opposites are the same, 4, 4, and 4, okay? So if I wanted to figure this one out, I do the same process as I did before, okay? Let's do the front face first. Now, when I was talking about that trick, what faces would be the same as the front? In a rectangle, the opposite side would be. So Mr. Back face, which is a happy, and he has like, I don't know what those are, teeth or tongues or whatever, right? So the opposite, the front and the back are the same. They have the same measurements. So whatever I get for the front and back, I'm gonna multiply that by 2, all right? The front times 2, and I'll get what the front and back are. Now, the right side, right? The right side is the same as the opposite side, which is over here. So these two sides are also the same. So the left and the right. And I'm only calling it that because of how I'm holding it like this. This is our front, this is the left, this is the right. And then we have our top and our bottom. All right, those two are opposite and they are the same. Top and bottom. Get rid of this. Go away. All right, so let's go ahead and go through each one of these and make sure we have the measurements for each one of them. All right, so the front has 6, and then perpendicular line, the height is 8. So we have 6 times 8. It's the same thing for the back. Then our left and our right. Now the picture is kind of showing kind of like this in a way. So we know that this line right here is 4 and our height is 8. Those perpendicular lines are what we use. So we have 4 times 8, and that'll be the same for the right. And then our top and our bottom. We know this line is 4, and then this front line is 6. Again, perpendicular. We can do these two if we want. We can do these two if we want. This is 4, this is 6. This is 4, this is 6. So 4 times 6. And we do that again for the bottom. So let's go ahead and multiply. 6 times 8 is 48. So whatever I do to the front, the back is the same. So that's 48. The left, 4 times 8. 4 times 8 is 32. All right, so this one is 32. 4 times 6 is 24. So that means this one's 24. So now, since we have the areas of each face, we're now going to add them up. And always look to see in this column, what can we do to add them up to make them easy? Well, 8 plus 2 is 10. 8 plus 2 is 10. So we have 20 so far. And then we have 4, and I notice this one's slightly off the screen. 4 and 4. So 20 plus 4 is 24, plus another 4 is 28. And I notice it's really off the screen. I wrote this kind of sideways, unfortunately. All right, so that is 8. So now, that's a little bit better. We're going to carry our 2 up here. So now I have 2 plus 4 is 6, plus another 4 is 10. Now I see these even numbers, so I'm going to go down here. So 10 plus 2 is 12, plus 2 is 14. Then I didn't add these 3 yet. So 14 plus 3 is 17, plus another 3 is 20. So 208. But we're not yet done because we have our number, but our unit, let's look back at the problem. Our unit says meters, M. And because we're talking about area, which is a 2-dimensional shape, right? It's not just 1-dimensional, which is a line. It's 2 lines that come together and create a shape. So it's squared. Our answer is 208 meters squared. Okay, so with this, the biggest thing to keep in mind is tip 1, remember what is the shape, what is it telling you, and what is the same. All right, it will save you time and work. All right, the second tip, cubes, super easy, all right, because you know all the sides are the same. So if you find the area of one face, you just multiply by 6 sides, or 6 faces, right? Every cube, pretty much anyone that we're talking about, any of the cubic prisms are gonna have 6 faces. But you can double check if you want, just to make sure, okay? So that's it for today. All right, tomorrow we're gonna go over triangular prisms, which is just a fancy word for prisms with the triangle, okay? Great job. Smells a lot better. By the way, it's PhD, not PDH.
You thought it was once, was it not what you think it was?
What?
Well, I made myself a cube.
You learned something from our video. Let me see.
Yep. See? It even has my favorite color on here, fuchsia.
That's just some pieces of trash, and it's not in the shape of a cube.
One person's trash is another person's igloo.
All right, yeah. Well, everyone, that is it for today. So make sure you like and subscribe, share it with your friends. We really appreciate when you do that. Helps us reach more people. And also make sure you answer the challenge question. All right, put your answer in the comments section below. And at some point you will find there will be a video that'll pop up about a sweepstakes. And any person that has commented on any of our videos from the beginning of our first video back to polygons, you'll be entered into a sweepstakes to win a custom Mr. B t-shirt in your size that doesn't stink a lot. All right, so make sure you go and do that. You can go back and watch those videos and do that so they can get added in. You'll be only the second person with a custom Mr. B t-shirt. The only other person is Mr. B. And believe me, you don't want his. All right, so thanks for joining us. We hope to catch you next time. See you later.